we are going to solve equations. And I know it's going to be weird, scary even. It's not that scary. Let's say I have the equation sine theta equals 1/2. Whoops, my marker's dying. That's asking the question, what angle gives me 1/2 as a ratio? Now we've learned that we can use the inverse sign to get the angle, but the inverse sign feature only gives me one answer. And if we think about like the graph of sine for a second, the graph of sine, let's go a little bit further, pi, 2 pi, 3 pi, 4 pi. Remember, it went up, down, up, down, up, and it kept going forever and ever. So how many times would it hit 1/2? What's going to hit it here, 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 here? It's going to hit it a whole bunch of times. So the way we're going to solve this is we're going to use our unit circle. We're going to find when sine is 1/2. Now remember, sine is the y value. So I'm going to look for a y value of 1/2, positive 1/2. So I'm looking for I'm using my big one, y value that's a positive 1/2. Here's one, and here's one. And I'm going to use the radian answer, so pi over 6 and 5 pi over 6. So 1/2 and 1/2. So I'm going to have two answers. I'm going to have pi over 6 and 5 pi over 6. What this is giving me is this point and this point, that x value and that x value, or that theta and that theta. Now it happens again over here, and over here, and over here. It's repeating itself over and over and over. Every plus or minus 2 pi n, over and over and over. I think the book actually uses a k instead of an n, so let's use a k instead of an n. 2 pi k, plus or minus 2 pi k. Because the period for sine is 2 pi, so we're just going to tack on a 2 pi k, over and over and over. Cosine. Cosine, we want to know, when does cosine equal negative square root of 2 over 2? Now cosine again goes on forever and ever and ever. So the first thing we're going to do is we're going to find when does cosine equal negative square root of 2 over 2. So cosine is the x values. So we're looking for an x value of negative square root of 2 over 2. And there's going to be two places on the unit circle. Okay. So negative x values would be over here. So here's one, 3 pi over 4. Oh, x value, 5 pi over 4. Now, when did cosine repeat itself? Oh, it repeated itself every 2 pi also. So I'm just going to tack on, and you don't even actually have to put the plus or minus. 2 pi k, 2 pi k. Keeps going. Now, what if sometimes they're going to give you a weird number, and this one we'd have to do a little bit of work on. Let's say they gave me cosine equals 0.65. Okay, so that one isn't on my unit circle. Oh, crud. Okay, so that one isn't on my unit circle. That's an x value of 0.65. So you circle. That's an x value of 0.65, so it's going to be somewhere like right here. Or it could be right here, right? X value 0.65. I need to know this angle. And I need to know this angle. So first, let's find this angle. That angle can be found by doing the inverse cosine of 0.65. And I'm going to use the TI if I can find it. Here it is. But you could also do the second or shift cosine in the NumWorks app if you wanted to. Now make sure we are in radians. Second cosine, 0.65, gives me an angle of 0.86. So this angle is 0.86 big. Well, remember, all the way around the circle would be 2 pi, right? So the other angle would be 2 pi minus 0.86. It'd be 0.86 down. So I'm going to do 2 pi minus 0.86, and that gives me my other angle is 5.42. Now, I have to tack on plus 2 pi k. Plus 2 pi k. Every single time. The only one that's going to be super weird is a tangent. Now, tangent, I can do in the calculator. Tangent is just a hair different. So all of these, we tack on a 2 pi k, 2 pi k, 2 pi k, 2 pi k, 2 pi k. On this one, whenever I find the angle, I'm going to tack on not a 2 pi k, but the period for tangent. And we didn't get a chance to do the graph for tangent, but if we had, we would have found that the period for tangent is just a pi. So we're going to tack on a pi k. So to find the angle, we're going to do inverse tangent of 2. So inverse tangent.
I don't need it.
Okay.
Thank you, though.
Okay. Inverse tangent of 2. And it gives me 1.1. We'll just go with 1.12. And that's it. So the nice thing about tangent is you only have to worry about one angle. And you have to remember it's only going to be 1 pi k. Sine and cosine, you have 2 angles, and it's a 2 pi k. So 2 angles, 2 pi k. 1 angle, 1 pi k. Now let's get to the harder ones. Oh no. What if it was 2 sine theta minus the square root of 2 equals 0? So it doesn't just have the sine theta by itself. Well, we'd have to solve for sine theta first. So we would add the square root of 2 over. So for those of you, I know some of y'all like me to show my work. Then we would need to divide by 2. Divide by 2. So we're trying to find when sine theta equals square root of 2 over 2. Take a minute if you want. Look on your unit circle. When does sine equal square root of 2 over 2? Remember, sine is the y value. So you're looking for when is the y value positive square root of 2 over 2. And you should have two answers. Your two answers should be pi over 4 and 3 pi over 4. But don't forget, two answers, we're going to tack on 2 pi k. What number? Number 6. Tangent squared minus 3 equals 0. Okay, so that would be, we have to add 3 to the other side. So I get tangent squared equals 3. So that would be, I have to take the square root of both sides. So tangent equals the square root of 3. Now, normally I would just go to the calculator, but that sounds familiar. I'm kind of remember getting tangent equaling square root of 3 a lot, especially in the formulas. Because that happened when I had like square root of 3 over 2 divided by 1 over 2. Right? And remember, tangent was y over x. Now, you could still do this in the calculator. That'd be fine. You would get a decimal for your angle. But if you can recognize that this is actually a point that has a y value of square root of 3 over 2 and an x of 1/2, you can do it a little bit faster because you could just look straight at your unit circle. And that is the point. Remember, tangent, we're only going to find the one point. And that point is pi over 3. And we're going to add pi. Okay. 1 point, 1 pi. All right. Now the hardest ones. Oh, I know. Oh no, you're like, what in the world? We got a cosine squared and a cosine and a number by itself. Something squared minus something minus 6. This should make you think x squared minus x minus 6. Something squared minus something minus 6. This factors. What would it factor into? Well, I know I'd have to have an x and an x. It would have to multiply to be a negative 6 and add to be a negative 1. So negative 3 and a positive 2. So that would be cosine theta minus 3 equals 0, because x is actually cosine. X was actually cosine, so this is actually cosine theta plus 2 equals 0. I'm going to split it up like you would if you were solving, and I probably should have thrown a step in there, that this is really cosine theta minus 3, cosine theta plus 2. Sorry, I should have put that in there. Now we're going to solve. So I'm looking for an x value of 3. And there are none. Why? Because my unit circle only goes to 1. Try it in the calculator. It's telling me there's an error. Cosine can't be 3. Well, what about a 2? Nope. Oh, it was a -2. Okay, try that. Nope. These don't work. Cosine and sine must be between -1 and 1. They can't be bigger than 1 or less than -1. So this one has no solution. This one, we have a mixture here, and this one has just a cosine here. I want you to realize that it's kind of like a cosine got distributed. We're going to factor out cosine. So we're going to put cosine theta on the outside of some parentheses. When I factor out or divide out the cosine from the first term, I'm going to have 5 sine theta left. And from the second term, it's just going to be the number 4. Now that it's factored, we set each factor equal to 0. Cosine theta equals 0. Cosine are my x values. So I'm going to look on my unit circle and find when cosine is 0. So cosine is 0, x value of 0, there and there. So this one is pi over 2 and 3 pi over 2. 2 answers, so we're going to add 2 pi k and 2 pi k. Now on the other side, I need to get sine theta by itself. So I'm going to subtract 4. And then divide by 5. Now -4/5 is good. It's between -1 and 1, but it's not on the unit circle. So to find the angle here, we're going to need to think about the circle. Sine are my y values, right? So they're going to be down here. So I'm going to get some point here. A y value that's negative would be down here. So the 2 angles I need to find are this one and this one. Now when I go into the calculator, it's going to give me a negative angle. It's going to give me this angle right here. So how am I going to find that angle right there? I'm going to go in, here I'm going to write it here, and I'm going to do inverse sine of -4/5, and that's going to give me my first angle. So quit that. Inverse sine of -4/5 gives me -0.927. That is right here, -0.927. To find this one, it's past pi a little bit, right? Oh, I forgot my plus 2 pi k, right? If I was going this way, I would go a pi plus how much? How big is that angle? Well, it would be pi plus 0.92 k. So I'm going to do that in the calculator. So that would be pi plus 0.92k, 4.06, basically 9, plus 2 pi k. Tomorrow, we can go over some of the homework problems together.